3 years ago, on August 21st, 2018, I achieved the first ever sub-30 single solve on the face-turning octahedron.
Yes!
At the time, this was the pinnacle cubing accomplishment for me, and I felt that the power in my new method was what allowed me to do what no one else had. But now, years have passed, many others have managed to do the same, and achieve even greater. Even so, I always try to recognize special occasions within the FTO community, and with this anniversary coming up this year, I had an idea. One of my favorite cubing related videos of all time is Sub-30 with 20 different methods by Tom Barlow, where he solves a Rubik's Cube in 20 different ways, each clocking in under 20 seconds. Back when I was first getting into cubing, this was just so incredibly impressive to me, as I couldn't even use one method to do it in under 30 seconds, let alone 20. Side note, that video is just about 10 years old, which is pretty neat. Link to it is in the description. After remembering about this video and a few other related ones, I instantly thought of trying something similar for FTO, and figured if I tried pretty hard and got a bit lucky here and there, I could maybe get sub-30 with 3 different solving methods. So it became a personal challenge. To make this even harder, I restricted myself in 2 ways. First, I would only allow myself to introduce methods created and developed by other people rather than coming up with new ones on my own. And second, I had to stick with using original LAN hardware. Now, granted, this one is modded and magnetized, but it would have been possible for anyone to do that if they were dedicated enough. There were lots of doubts. Would I even be able to find 2 older methods viable enough for getting a sub-30 solve? Would I be able to learn them, and do it all in a reasonable amount of time? As it turns out, the answers to those questions were yes. The methods I ended up using were Bensisco, of course, the reduction method, and Julian's method. The latter 2 were each discovered and published prior to 2010 and offered potential move counts that were comparable to Bensisco, so as to why I went with them. Now all 3 methods have the same first step, which is starting by solving one center, but they deviate quite significantly afterwards, which is nice since it means the methods are truly different from one another, rather than being variations on a pre-existing one. And as for the learning curves, I ended up not having to really learn any new algorithms. It was more so reapplying the concepts I already knew, but in different ways. I started going for the challenge near the end of June this year, and managed to complete all 3 solves by August 19th, 2 days before this special occasion. So without further ado, here they are, along with reconstructions and explanations for each. Wow, all I wanted was sub-30. What is that? There we go. 2423. So the first solve here was done with Bensisco, and unsurprisingly it was the fastest of the 3. So I'll run through this one pretty quick. So here's what the scramble looks like, and for all of these I will have the scramble up at the top of the screen that you can follow along with if you want. But yeah, let's get into it. So the first thing I see in inspection is I have this pair right here, and then I have this edge over here, and I realize that if I bring this edge to this position here, and then I can bring this pair to match and make a large trapezoid. So I guess from the original angle I rotated to here, and then I brought this edge down here like this. I then matched out the pair with the edge on this side, and there's my large trap. And doing that also formed this pair with the remaining edge, and then the remaining white triangles here. So I matched them up finally like this, and then brought it all together on top to make my center right there. So now I have my first 2 triples, so I rotated to this angle and saw that I have this pair, and then here are these 2 triangles. So I can match up a blue triangle on this side of the corner with these moves like this. There it is here. Then I bring it down here, and then I bring it in next to the first center, just like that. And that's my first triple. Then rotating up here, I then see that I have this pair, and it's almost done with the actual triple, it's just missing this triangle. So I do U prime here to put it in the right, and then I see this triangle here. So I do R prime, U prime, R prime, match it up in the back, and then bring it down and match it up once again. And now my first block is done. So from this point I move on to the second center and I rotate here, and I see that I have this pair with these purple pieces, and then here's this edge. So if I bring this down, I can actually make a large trap for this center. And miraculously, it also actually brought down this triangle over here to then make the small trap as well. And I didn't actually see that was going to happen. So I ended up going into orienting this first before this one, although that was a little bit of a minor inefficiency. It's okay. So I rotated it like this to put it in the middle slice layer, bring it back down and rotate now this small trap into position. And then I bring them together like this, orient the center, so gray is on the right, and then put it in the back, and now we're on to the last two centers. At this point I saw this really nice collection of pieces for orange on top, and I saw these edges on the front face, so I decided to go for a large trap on the front. So I rotated to here, and then did U prime, R prime, U prime, R to get me a large trapezoid on this side. Then bring it back down. I then had this small trap case, which can be solved like this. And now I have both these centers done. This one was already oriented, which is nice. And then I went ahead and oriented this one just like that. So now for my last bottom triple, I saw that I had this pair, and then this triangle is actually right here that's going to be matching up on the other side of this corner, so it was already set to go. Theoretically, I could have actually canceled into this flip alg from the center orientation, but that's alright. So then I did a lefty slice like that, and then an R prime matches up the whole triple. Then I bring it up, and then I need to insert it over here on this side, so I did it like this. And now the last bottom triple is inserted and my first two layers are done, so rotating here and then fix the bottom just like that. Finally, for last three triples, I rotated over here, and then I saw that I had an odd permutation case, and these two pairs were already formed. And I realized that if I do a hedge from this angle, it'll solve my corner permutation and also shoot this triangle to the non-matching slot, which is a nice case because that gives me the 9-move odd TCP. So I did a hedge here, rotated to this position, and then I see that to set up the AUF for this algorithm, I do a U move to place the blue over the blue, and then I do the odd TCP alg here, and we're solved. No AUF. The final solve time was 24.23 seconds. The total move count was 68 moves, which gives 2.81 TPS, which is actually pretty decent for me on an average Bensisco solve. Now, because I've been using this method for so long, I really don't have any statistics on my progression for at least this particular challenge. And it's also been a while since I actually did the solve. I think I just sat down and did maybe like 4 or 5 solves and then got it pretty quick. And yeah, you can tell in my reactions, like, surprised that I got sub 25. All I was going for was the sub 30. Just for fun though, here is a graph of my progression with Bensisco at 2018. When I was first starting out, you can see I was doing a lot of solves, and it took me actually a very long time to get sub 30 originally with my method. But again, this was because I was developing it at the same time, and people nowadays can progress much faster. Alright, first solve out of the way, let's move on. Yes! There we go! Whoo! Look at that. Boys, there it is. Nice. So the second solve was done with Julian's method. Once again, scrambles at the top of the screen, and here's what it looks like. So the first step is the same solving one center. In inspection, I see that I have this pair right here and this edge, and I can bring them together very easily to form a large trap on top. And also the small trap in the back over here is going to be preserved with those moves, so this is only going to be a 4-move first center, which is really nice. So from this angle, I solved it like this to get the large trap, and then moved it out of the way, and then brought the small trap in just like that. And that's my first center. Now the next step for Julian's method is to solve two arrow blocks next to this first center. So I rotated here and we can see that there's a really nice triple already solved here. So I decided to match it up next to the center correctly. So from this angle, I just did that to reposition it next to the center. And then rotating down, I see I have this pair with this edge in this triangle, and here's another edge in the back, so I can make the large trap that matches with this triple very easily. So I did R wide U to put it into position. Then I actually did 2 wide moves for some reason, and then did an R, and as you can see that forms that. And then I can position it in the middle slice layer like this and bring it down, and there's the first arrow block. So now going for the second one, I see for this triple over here I already have one triangle matched up, so I decided to go for this one, and I just need the red triangle. So I bring it into this position, and then this red triangle shows itself over here. So I do R prime U prime R prime, and that forms it in the back, and then a BR will slot it into the back like that. And then I got to get the large trap for this one, so I do an R wide prime, and then I get a really nice case here, this pair with this edge in this triangle, and then here's the other edge over here, already set up, ready to go. So I match them up like this, and then a U, R wide, puts it in the back, and there are the 2 arrow blocks done. So this part of the solution is actually still pretty straightforward. We're kind of just doing block building strategies, very similar to the ideas behind most of the Bensisco method really, but also kind of solving some of the middle layer pieces along with the first block, which is pretty cool. So the next step here is going to be to solve the last corner piece in that first layer and this large trap next to it. So similar to those other arrow blocks, but we're kind of leaving out some triangles because it's just too annoying to include them. So the first thing I see is that I need to get the orange triangle to match up on this side of the corner piece as part of that block. And I see this one over here, and so I decided to put it in the back like this, and that matches it up over here. Something to actually note with that though is that I already had an orange triangle in the back, and I actually missed this in the solve, but it's okay, whatever, it's just a couple moves. So again, we're back to here, we have this matched up, and then I bring it down here. And next I'm going to match up this corner triangle pair next to the yellow edge piece, which is this one. So I do it just like this. Now I have this matched up, and then I'm going to match up the blue edge on the other side. So U, R prime to bring it back into the top layer here like this. And then to match it up, I do another U, put most of the block in this right layer, and then R, U, R prime finishes that whole block, and then we just position it like this. So now you can see this is solved. Technically speaking, in Julian's original method, these middle layer triangles that are being solved with the large traps are optional, but since I wanted to go for a fast solve time here, I chose to always include them, so that way I would have less algorithms potentially to execute at the end of the solve to finish, which would increase the chances, of course, of getting a lucky solve. So now the next step for the method is to solve the last layer corners. So I rotated to here, and then first fix the edges. So I do a U move here to align the edges with all of those large traps I just finished. And these are always going to be alignable. There's no algorithms here. These edges are automatically going to be solved. And all we have are the corners. So in this case, as you can see, we have a 3 cycle of the corners. And if you're familiar with the Bensisco method, we have an algorithm for CP, of course. So I chose to use it here, which looks like this. And now corners are solved. Now what's really interesting, if we go back a second, is that this is actually part of Julian's method where you can be really creative. There is actually shorter algorithms that we can use for most of the corner cases. For example, for this one, we can actually use this 7-move algorithm to solve corners, as you can see here. However, if we look at the actual case we had with our triangles, we can see that 3 of them are already solved around this top layer right here, and that algorithm would have scrambled them up, which would have been worse. So as it actually turns out, the CP alg that I used was the best choice, which is quite nice. So now after all the corners are solved, we finally are just left with a few triangle pieces. The worst case you can get is all 14 of the possible remaining triangles unsolved. However, for this solve here, I actually got really lucky and only had 8 unsolved triangles. And so now I just needed to finish them with commutators. So I rotated to this angle here, and I saw that I had this red one, yellow one, and gray one in this orbit here, and realized that I could solve all 3 in one go by setting up this triangle to be in this position, and then using this com. Just like that. Solves all three of those. Then I undo my setup move. And I thought actually during the solve that I was completely done with that, but realized, oh shoot, I have this blue triangle up here, so I kind of rotated here and then over here, and then I saw that here was the other triangle. So then I used a com to cycle these three triangles, which looks like this. And now, as you can see, these two are solved now. And then finally, at this point, I had just these three triangles left. So I did my final commutator. I set up this one to be in the back over here. And then finally used this commutator. And then undid my setup move, and we're finally solved. The final time was 29.91 seconds, so pretty clutch. The solve itself was 83 moves in total that I performed, with 2 extra ones that could have canceled out, which overall gives 2.77 TPS. I was actually really surprised I was able to pull off such a high turn speed with this method, to be honest. Which I definitely needed, since the move count for this method generally tended to be higher than the other two. So finally, here are some fun statistics. Overall, it took me about 173 timed solves or so to get the sub-30, and you can see the progression here in this chart. The spikes that you see on the graph here that shoot way up represent DNFs. I was actually quite surprised that it took this few solves. I was expecting it to take quite a lot more, so, I guess I just got a little bit lucky. Out of this entire set of solves, my best average of 5 clocked in at about 40 seconds. So if you were to use this as a main method, you could probably realistically push sub-40 averages. But I think the main downfall that stops this from contending with Bensisco as a speed method is the fact that most solves have too many moves, especially at the end, where you're doing a lot of slices for commutators, which is just not very ergonomic. The start of the solve can be really fast though. It's a lot like Bensisco with its block building techniques, and it is really neat to see this kind of method existing even as far back as 2009. Alright, let's move on to the last solve. Yes! Finally! Oh my goodness, that was the last one. Yes! Ladies and gentlemen, woohoo! Alright, so the last solve was done with the reduction method. This is also the same method that Michael Gottlieb used way back in 2011 to set the original world best of 1 minute 4.8 seconds. So it's pretty crazy to see that same method get sub-30. As always, the scramble's on the top of the screen if you'd like to follow along. So in the inspection, I'm going from, again, my first center, and I see that I have this large trap already done with these white pieces over here. And then I have this pair over here and this triangle over here. So this is a pretty nice setup for a first center. Now for lots of these solves, I was actually choosing to go for other center colors as my first center just because it would just help with the efficiency. But as it turns out, for the solve that ended up being the sub-30, I went with white first. It is what it is. So for this, I positioned this triangle to be down here to then match up next to this pair like this. And now I have my small trap done, and then I'm going to insert it on the underside of the large trap. So I brought it down here and then did a D prime. And there's the first center. So now after this, I then move on to a second center. And I see that I have this green pair over here, which is pretty good, so I rotated down, and then I saw that there's this pair over here, so I can bring these up together to make a large trap like this in the back over here, and then a U-prime to put it in the middle slice layer. And now I'm going to finish the small trap, so again, I rotate over here, and then I can bring this triangle that was over on that side down to make this pair, and then it was at this point of the solve that I realized that the other triangle that had shot to the back there wasn't in the right position, so I was going to bring it down, but as you can see that doesn't work. So then I did another U move, and then I did this, bring it down and repositioning it like that. And then we can pair it up like this, and then insert it in the back to finish the second center. Now in the reduction method, you're free to use F, BR, and U moves when you're doing your E center, so really I should have taken advantage of that and it would have made the solution a little bit better, but that's alright. So now for the last two centers, that's these two. I saw that I have this pair for orange on top here, and then here's the edge piece, and sure enough, it is going to be the correct color scheme. So I matched them up like this, and there's my large trap done. And what I noticed here is that the large trap is in this L slice over here. So actually I can finish both these centers without having to reposition these faces by doing a rotation like this. And now I have this small trap case which I can solve like this. And there's my last two centers. Now, in reality, a rotation that extreme is actually pretty bad. Realistically, I should have just done the extra moves to reposition the traps to be a little bit nicer and executed it from the same angle. But it's whatever. It's cool to be able to see this trick that you can use with reduction, but you can't use with Bensisco, because otherwise it would break up your triples. So the next major stage of the solution here is to then match up all of the triples, essentially pairing them, a bit like edge pairing on a big cube, for example. So what I did is I saw this pair over here, so I rotated it to place it on my bottom layer, which is the interface that I use to match up the triples. And now, in order to match this, what I need is a red triangle over in this position, and I actually didn't know what to do, so I kind of did U prime, U prime, U prime for pretty much no reason, but realized I have this red triangle right here, so I brought it down like this, and then the D move will pair up this triple, as you can see. So now I need to replace this with another triple from the top, and I was going to go with this one, but I realized that this one was a little bit nicer. This has this pair over here, and this is yellow. So if I bring this down here, it's going to match up with the yellow one I slice back and form two triples. So that was going to be pretty nice. So then I rotated to this angle, and then inserted it like this into the bottom, and then I rotated it back just like that. And miraculously, this first comm actually solved 5 of my 6 triples. This is insanely lucky. I definitely wasn't planning for this to happen in the solved, so to see that was pretty crazy. And it was at this point that I really started panicking, because I looked over here and saw this unfinished triple and was thinking, oh shoot, is this the last one that I need to finish? And I actually kind of just guessed and assumed it was and went for it, and it turns out it was right, so that was nice. So from here, I then rotated this way, and as we can see, this last triple case has this corner twisted 180 degrees, and this really isn't the greatest case ever, but there is a pretty nice way to solve it. What I needed to look for was another blue triangle in some other triple, so I kind of looked on top and saw, oh, there's this one over here, but I realized if I bring that down, it's actually on the bottom side, which is wrong. I need it to be on the top. But doing that move, I saw this triple over here with this blue, and so I turned it back and realized, yeah, here we go. Here's the blue triangle up here in the middle slice. And so from this point, I then did a D prime move from this angle, and that now made this. So now we can see, if I flip this triple over 180 degrees, it will twist the corner, but essentially not affect these other two triangles, which is what I want. So then from here, I took this triple out from the bottom layer, like this, and then rotated here and inserted it back in from the back from this angle. And as you can see, that corner is now twisted over. And then finally, a D move to restore the bottom slice, finishes that last triple, and now they are all reduced. So now the final stage of solving is to essentially solve the reduced pyraminx, or pyraminx without the tips on it, with, I guess, a weird color scheme. And there are many ways you could do this, but the way that I like to do it is to kind of solve my first block, first layer, and then do my last triples, kind of like Bensisco, if all the triples were done, I guess. So I first saw this one, and I'm going to match it up next to this center over here, so I rotate to this angle, and then insert it down like this. And then I also noticed that I had this white triple too that was matched next to the center as like a pseudo triple, so I decided to go with that. So from this point I rotate down so these two triples are on the bottom, And now I'm going to orient the rest of my E centers. So I'm going to make sure the gray is on the right, so I see this one first needs to do a U prime. Now it's oriented. Then I do a wide move like this, and orient this one like this. And I do have to be careful orienting the centers that I don't accidentally shoot the last triple into the slot, because then that wouldn't be very good for a case like this. But luckily that didn't happen. And then finally I had the last triple to insert. But I can do this cool insert here, where I actually did an R wide and then an R wide again. Essentially, placing this triple above this one, and then I did this, and that solved my bottom layers like that. Both these triples are now in, all the centers are oriented, and finally I have my 3 remaining triples on my last layer, kind of like in Bensisco, so I rotate to this angle, and finally solve all 4 triples like this. And there it is, we're finally solved. The final time was 29.34 seconds, so actually quite comfortably sub 30, which I wasn't really expecting. The solve overall had 64 moves that I actually performed, and actually 8 of them could have been cancelled in the solution for a crazy 56 move solution. But 64 moves gives 2.18 TPS on the solve, which, as you may be able to see, is not very fast. What I experienced with reduction is that the TPS in solves is often a lot lower because recognition during the triple reduction stage is just so insanely hard. Keeping track of all of the triples that are already solved, as well as the ones that still need to be solved, figuring out which triangles to insert where to make the pairs, it's just really complicated. And ultimately, that step of the method is what really renders it inferior to modern approaches. Now the crazy stats, it actually took me 252 timed solves to get the sub 30 with this method, and I was not expecting this either. I assumed reduction would actually be the easier of the 2 other methods compared to Julian's method, and that I would get it much quicker, but it turned out the opposite was true, which is pretty crazy. The triple reduction stage just killed so many potentially good solves and ruined a lot of really fast times. What's also really funny is that I had really good averages that came up with this method during this session. Because I did more solves, I obviously was able to go for better averages. My best average of 5 was 32.9 seconds, and my best average of 12 was 39.8 seconds. That's right, they were both sub 40. Granted, the solves that I did get this on were ridiculously lucky. In fact, it's actually close to this point right here, which you might see. This was actually a 30 flat single solve, which was just really unfortunate. You can also see in this progression that I had way more DNFs with the reduction method compared to Julian's method even. These were due to either me just giving up on solves because of really bad cases or getting wrong color schemes. So overall, this method was extremely frustrating, felt very grindy, and honestly was just not fun. I definitely would not be going for another sub 30 with reduction. But at least it's nice to have some consolation that the original method that Michael used to get the original records was capable of sub 30 times. But there it is, the 3rd solve of the challenge, and achieving sub 30 with 3 different methods. My main takeaway from completing this whole challenge is really 2 things. First, we can see that it was totally possible for FTO solving to be this fast way back in the day. It was just that no one really put in the effort necessary to get there. Again, both of the alternate methods I used to get sub 30 here were originally conceived over a whole decade ago, and the current hardware isn't much different from that time either, so not much was stopping anyone. However, there were other things that were different. The community was smaller, most people didn't really bother dedicating practice to non-WCA puzzles like this, and those who did often weren't speed solvers. I think the cubing culture from back then played into a lack of FTO development, which could be one reason why it didn't take off sooner. But the main realization here is this: Bensisco is simply not the end-all be-all for FTO solving. So often in cubing and even other activities, we take the current methods for granted and roll with them because, well, they work good enough and lots of the heavy lifting is already done for us. But that doesn't mean there isn't something else still undiscovered that could be significantly better too. By now, many WCA events have multiple top methods that are nearly equally viable. CFOP and Roo for 3x3, Yao, Redux, and Hoya for big cubes, and so on. And I, for one, would love to see something new come along that can compete with Bensisco for FTO. And perhaps the older methods, despite being somewhat less efficient compared to modern techniques, can help spur some new ideas there. So I hope you enjoyed the video. This was a really fun challenge, and here's to more great progress in the FTO community. Thanks for watching.